Hi everyone, so in this video we're going to continue talking about Chapter 1, Algebra and Function Basics. Specifically, we're going to go into topic 1.2, Definition of a Function. And here we are with example 1.11, and part A says, express the volume of V of a cube as a function of the length E of each edge. So, in this case, they just want us to express the volume in terms of E, the length of each edge. So because we want to use function notation, we would say V as a function of E is equal to E cubed, because that would give us the volume in terms of the length. Part B is a little bit more difficult because they want us to express the volume as a function of its surface area S. We know that the surface area of a cube would be equal to 6 times the area of each square. So 6 times E squared. So we have to rearrange this and make it E equal to something S, right? So let's just turn this around and we can say that E squared is equal to S over 6, and therefore E is equal to the square root of S divided by 6. Now notice that I'm not using a negative sign here because we're talking about lengths. Therefore, all the values that we're interested in are positive. So now that we have an expression for E in terms of S, we can plug that in here, and we will get a function of the volume in terms of area or surface area S. So we can say that V of S is equal to, because it's equal to E cubed, it's going to be equal to the square root of S over 6 cubed. And notice that this is the same as saying S over 6 times the square root of S over 6. Okay, so now we are in example 1.12, which is a word problem. And it says, an offshore wind turbine is located at point W. So this is point W, 4 kilometers offshore from the nearest point P on a straight coastline. So because it's the nearest point, that means that this has to be a right angle. An engineer is returning by a small boat from the wind turbine. He sails to point D, that is located between P and M at a known distance x from point P. So he sails from W to D, which is here. And then from there he walks to the maintenance station. The maintenance station would be M. The boat sails at 3 kilometers per hour, and the engineer can walk at 6 kilometers per hour. Express the total time T in hours for the trip from the windmill or the wind turbine to the maintenance station as a function of x kilometers. Okay, so for this, we have to remember that speed is equal to distance over time. Therefore, time is equal to distance divided by speed. And notice that these two distances, WD and dm, can be expressed in terms of x, because WD, using Pythagoras, would be the hypotenuse of that right triangle. So WD would be equal to the square root of x squared plus 4 squared, or 16. And then dm can also be expressed in terms of x, because if we know that the total distance here is 3 and that this is x, then dm must necessarily be 3 minus x. Then we have everything to set up the function. So we would say t, time, in terms of x, is equal to distance over speed. So for WD, the time would be the distance divided by the speed. So it would be square root of x squared plus 16 divided by the speed, and the speed of the boat was 3 kilometers per hour. So that's the time it took from W to D, plus 3 minus x, the distance between D and M, divided by the speed of 6 kilometers. And then we can just rewrite this as T of x is equal to 1/3 square root of x squared plus 16 plus 1/2 minus x over 6. Okay, very well. So next we are on example 1.13. And here they want us to find the domain of each function. So the domain. Now remember that domain refers to all the x values or the values that you are allowed to plug in the function, right? In case it's not x. So for letter A, notice that we are given a list of coordinates. So here we have these coordinates. So the domain, in this case, the domain would be equal to all the x coordinates of these points. So we make a list: -6, -1, 2, 3, and 5. This is what's called discrete data, not continuous data, because it's a set of points. For B, they talk about the volume of a sphere. And notice that it's the volume in terms of r, the radius. So the domain is going to be determined by the radius. And because we're talking about volumes, the radius then must be any number greater than 0 with r belonging to the real numbers. So that would be the domain of the volume of a sphere. For C, we have more of a classical function. And it says that y is equal to 5 divided by 2x minus 6. So what we have to determine here is what are all the possible values that we can use for x. Now the only restriction here, because this is a fraction, is the fact that we cannot divide by 0. Therefore, we can say that 2x minus 6 cannot equal 0. That would be the only restriction. So if we solve for x, we're going to get that x cannot equal 3. Therefore, the domain, we can say that x belongs to the reals, or x can be any real number, but x cannot equal 3. For example D, we also have restrictions in the case of square roots. We know that square roots cannot be negative. They can be 0, but they cannot be negative. Therefore, the expression 3 minus x must be greater than or equal to 0. Then minus x must be greater than or equal to minus 3. And then remember that if you have an inequality and you divide it by a negative or multiply it by a negative, then this is going to flip. And we're going to get that x must be less than or equal to 3. So that means the domain is x belongs to all reals and x is less than or equal to 3. So next we have example 1.14, and it says find the domain and range for the function y equals x squared. Y equals x squared. So first we're going to look at it algebraically. So what would be the domain for y equals x squared? Now what restrictions do we have here for x? We have none, right? There's no restriction. We can plug in anything and square it. That means that the domain is all real numbers. Now we're going to introduce proper notation for this. So there's one thing called set builder notation. And in set builder notation, we would write the domain in the following way. we would use a bracket and then say x is such that x belongs to all real numbers. So this is one type of notation. The other type of notation is using intervals. And for the interval notation, we say x belongs to negative infinity, comma, infinity. Okay, so how about the range? Well, in this case, the range is always going to be positive because if you square any number, the result will be positive. So, and you can see this in the graph right here. Notice that the range starts at y equals 0. We would say then that in set builder notation, we would say that y is such that y is greater than or equal to 0, and y is real. Or in interval notation, we would say that y belongs to 0, including 0. That's why the square parenthesis is going inwards to infinity. With infinity, you always use an open square parenthesis. In the next slide, you're going to see something called function notation. And basically what we have here is two different ways in which the IB refers to functions. The first one you're probably already familiar with, where we have something like f of x equals x squared. You could say the function f in terms of x is x squared, or simply f of x equals x squared. And this is maybe a little bit different or novel, but it's the same thing. What they say here is the function f maps x to x squared. So what are two examples of these? F of 3 equals 9, or the value of the function f when x equals 3 is 9. And then for this one, we would say the image of 3 under the function f is 9. Now, this is known as the image of 3. And 3 can also be referred to the pre-image of 9. So 9 is the image of 3, and 3 is the pre-image of 9. All right, so now we are in example 1.15, and it says, find the domain and range of the function h such that x maps into 1 over x minus 2. So this is what's called a reciprocal function. And with reciprocal functions, you have to take into account asymptotes. So the asymptotes are values through which the function cannot cross for whatever reason. So vertical asymptotes, those would be the values of x that we cannot plug into this. And notice that the denominator by definition cannot equal 0. So that means that x minus 2 cannot equal 0. In other words, x cannot equal 2. And we can see this clearly on the graph to the right, where there is a vertical asymptote represented by this dotted line that goes through x equals 2, where the graph does not cross, because if x equals 2, it becomes undefined. Then we have the horizontal asymptote. Now the horizontal is a value that this function will never meet for y. And which one is that? Well, that's 0, because this will never equal 0. This will never equal 0. The reason being that if you have a 1 in the numerator, there is nothing you can divide 1 by to get 0. So that means that the function just cannot cross 0. And we can see that in the graph here, where the horizontal asymptote is the line y equals 0, which is the x-axis. So y cannot equal 0. So with this information, we're ready to write the domain and range. So the domain, which is always in terms of x, says in set builder notation, x is such that x is not equal to 2, x is real. Now we can do this backwards as well. We could write x is real and x is not equal to 2. In set builder notation, we would say, well, from negative infinity to 2, not including 2, union 2, also not included, to infinity. And the range for y would be pretty similar. We would say y is such, and we'll do it backwards this time, y is real, but y cannot equal 0. And then in this other notation, we would say from negative infinity to 0, union 0 to infinity, also not including the 0 in either one of these intervals. One thing I forgot is to say that we have to write x belongs to this interval and y belongs to this other interval. Very well, so next we have example 1.16, and it says consider the function f of x equals square root of x plus 4. Part A, number 1, find f of 7. So remember that that's just plugging in the 7 in the function, right? So f of 7 would be equal to the square root of 7 plus 4, and that equals the square root of 11. And if you plug that in the calculator, it's going to give you approximately 3.32. Now this is very important because normally in the IB, you're going to round to 3 significant figures. They expect you to round to 3 significant figures. Okay, so for number 2, we have to do f of 32. So f of 32 is just going to equal square root of 36, 32 plus 4. And this is going to be 6. And then part 3 is f of negative 4. F of negative 4 is just going to be square root of 0, which is 0. Okay, so for part B, they say find the values of x for which f is undefined. So because f of x is a square root, we know that square roots are undefined for negative numbers, at least when we talk about real numbers, right? So that means that where is x undefined? X is going to be undefined when, or f of x is going to be undefined when x plus 4 is less than 0. So that means that it's going to be undefined for all values of x that are less than negative 4. For C, they say state the domain and range. So the domain would be the opposite of this, meaning that the domain would be x such that x is greater than or equal to negative 4, and x is real. And then, or I should say, we can also say, well, x belongs to an interval notation. We would say including negative 4 to infinity. And the range, which is in terms of y, would be that y is such that y is always going to be greater than or equal to 0. We can see that in the graph here. Notice that for y, it starts at 0 and goes to infinity. So y must be greater than or equal to 0, and y is real. Or in interval notation, y belongs to including 0, comma, infinity. So finally on this video, we're going to be doing example 1.17, and it says find the domain and range of the function f of x equals 1 over square root of 9 minus x squared. Okay, so this is another reciprocal, and we know that normally we could plug in any value except 0 in the denominator, but in this case, because we have a square root, we can't have negatives. That means then that 9 minus x squared must necessarily be greater than 0. 9 minus x squared must be greater than 0. So how can we find out which would be the domain here? What we have to do is factor this. And notice that this is a difference of squares, so we could rewrite this as 3 plus x times 3 minus x. This must be greater than 0. And then we take the critical points. The critical points are the ones that would make this equal to 0. And notice that they are negative 3 and 3. And what we do with these two values is that we create a sign chart. Okay, so what happens if we plug in a value that is less than -3? Let's say -4. So if we plug in -4 here instead of x and here, we're going to get a negative number, right? Because 3 minus 4 is -1, and this 3 plus 4 is 7. We're going to get a negative value. And so forth for anything that is less than -3. But if we test a value that is between -3 and 3, like say -2, what are we going to get? Well, we're going to get a positive. We can see that easily, right? We get a positive. What happens if we plug in something that is greater than 3, such as 4? Well, we're going to get a negative value again. You can test that for yourselves. What does that mean? That means that 9 minus x squared is going to be greater than 0 in this interval here. So that means that the domain is x such that x is greater than, not equal to, because that would make it 0, which is undefined. So it would be x would be greater than -3, but less than 3. And don't forget always to add that x is real. If we were to use interval notation, we would say, well, x belongs to open -3, 3, and open. This means that it doesn't include -3 and it doesn't include 3, but it does include all the real values between those two numbers. How about the range? So for the range, we have to think about this here, the function itself. So if we have 1 over square root of 9 minus x squared, what would be the lowest point on the graph of this function? Because this is a fraction. This is a fraction, and you have a 1 here. When will this fraction be the smallest? Well, it'll be the smallest when this here, the denominator, is the largest. So when is this the largest? Well, when x equals 0. So what happens when x equals 0? Let's test it. So what is f of 0? F of 0 is 1 over square root of 9 minus 0, so just square root of 9. In other words, 1/3. 1/3. That would be the lowest value. Anything else in the interval between -3 and 3 will be larger than that. So what this means, therefore, is that y, or the range is going to be y such that y is greater than or equal to 1/3, and y belongs to the reals. Or in interval notation, y belongs to, in this case, we need a close parenthesis, because 0 is included in the domain. So is 1/3 in the range. So 1/3, comma, infinity.